In this assignment, we've looked at some organic molecules and try to understand how certain organic reactions work. So our first question here asks about which of these alcohols are primary, secondary, or tertiary. So a primary alcohol is attached to a carbon that is either by itself or attached to only one other carbon. So this hydroxyl that we see here is attached to a carbon that is only bonded to one carbon. So that's a primary alcohol. Whereas this hydroxyl, the alcohol group, is attached to this carbon and it's attached to two other carbons. This is a secondary alcohol, but this is a primary alcohol. Here, the hydroxyl group is attached to this carbon, and that carbon is attached to three different carbons, so it's a tertiary alcohol. So the primary alcohol is molecule 2, the secondary alcohol is 1, and then 3. Most people seem to have a pretty good time with that. Now, this says the reaction of an unsaturated hydrocarbon. So if it's an unsaturated hydrocarbon, we know it's going to be an alkene or an alkyne. To produce molecule 2, so if we were going to use an addition reaction, we could add to the double bond, and if we wanted to make this molecule and get a hydroxyl, then the carbon that has a double bond has to occur in here, right? If I want to put the hydroxyl in this space here, I'm going to want it to occur in here. So I need that to be where I have my double bond, and it would be a pent-1-ene. The next question says, when three molecules are mixed with water, they should be, well, all of these should be quite soluble because the hydroxyl group that we've got on these is very soluble in water. It has a hydrogen bonding, and these are relatively small molecules, so they should be soluble in water because they have a hydroxyl group. Now, a carbonyl group is like this, right? And we see a carbonyl group in carboxylic acids, but not here. You'll also see carboxyl groups in esters, and that's an extra topic that I'm encouraging you to take a look at when you're done doing the unit test. Now, this question says, complete the reaction of butane-2-ol with an acid catalyst. Draw all reactants, possible products. So I'm going to first start with my butane-2-ol. So I got my hydroxyl here, so I'm going to get these hydrogens, fill it up. And so each carbon's got a total of 4 bonds, right? So if this bond is here, then we get 3 hydrogens. This second one has 1, 2, 3, and then the fourth is a hydrogen. The next one has 1, 2, 3, 4, and the final one has 1 and then 3. So those are going to react. It's got a catalyst, and there's nothing else to react. So really, the only reasonable thing that can happen is going to be an elimination reaction. So an elimination reaction will take the hydroxyl and an adjacent hydrogen to make water. And that adjacent hydrogen could come from here or here. So if the hydrogen came from here, it'd be CH2, double bond CH, CH2, CH3, and a water. And if instead the hydroxyl or the hydrogen came from here, you'd have CH3, CH, double bond CH, CH3. And so this first one that I've drawn is but-1-ene, and the next one is but-2-ene. And if I wanted to balance it, and I don't think it asks for balancing, but if I'm going to make 2 of the alkenes, then I need 2 of those, and it's going to also make 2 waters. The next question has the complete reaction of 1,3-dichloropropene with chlorine. So now, anytime you've got a reaction and it's got a double bond, I instantly think this is going to be an addition reaction. What's going to happen is one of these chlorines is going to get attached to this carbon, and the other one gets attached to this carbon. So I'm going to have HCCl, HC, ClH, so that was this chlorine attaching here. And then this is going to be ClH, and then that last chlorine gets bonded here. Now I need to name this. So this is going to be a propane, right? Because it's all got single bonds. But it's got 1, 2, 3, 4 chlorines. So it's tetrachloropropane. And I need to number this to get the lowest number. So if this was 1, 2, 3, I'd get 1, 2, 3, 3. But that gives me a higher number than if I go back the other way and I go 1, 2, 3. That'd give me 1, 1. So 1, 1, 2, 3 tetrachloropropane. Our final reaction has propane reacting with chlorine. So this is a substitution reaction. If I've got an alkane reacting with halogen, I'm expecting that that's going to be a substitution. And essentially, I'm going to have my 2 chlorine atoms here. One of them is going to bond to a hydrogen to make hydrogen chloride, and the other chlorine will bond in its place. So we're substituting it out. So I can get CH3, CH2, CH2, Cl. And this will be 1 chloropropane. But I could substitute a hydrogen here as well, and what I'd get is CH3, CH, Cl, CH3. And that'd be 2 chloropropane. And another hydrogen chloride. If I had that, I need 2 of these and 2 of these to balance it. So I'm going to get 2 chloropropane and 1 chloropropane being produced. There is no 3 chloropropane. So if instead we'd put the chlorine on the first carbon, we would actually end up just making more of this. So that's how we do these questions, and hopefully that helps out.